Okay, let us go on to the next question, which is related to your empirical formula concept. Okay, so the question is really very simple. As you can see, an organic substance containing carbon, hydrogen and oxygen having percentage composition as carbon 40.687, hydrogen 5.085%. Okay, now only carbons and hydrogen's percentage is given, students. Oxygen's percentage is not given. Continuing the question, the vapor density of the compound is 59. Calculate the molecular formula of the compound. Okay, so the first and the foremost thing what you can do over here is, student, that by addition of carbon's percentage and hydrogen's percentage, you need to subtract that total from 100, because any compound's percentage composition obviously would not exceed 100%, right? So 40.687 plus 5.085%, and you need to subtract it from 100. So you will get the percentage composition for the oxygen, students. Clear? So that's the first catch what you need to understand here. Now when you will do that, you will get the oxygen's composition as 54.228. Okay, please in the rough do this calculation. You need to add 40.687 plus 5.085 and the addition amount of that subtracted from 100. Okay, another important catch over here, student, is you have been given vapor density of the compound. Okay, now for the vapor density of the compound, students, you remember one thing, that the molecular mass of that compound is nothing but equal to twice of vapor density. Okay, I guess you have learned this concept. Okay, molecular mass of the substance is equals to twice of vapor density. Clear? Now, after clearing all this, let us begin with the actual solution. The actual solution of this question begins with the one of the important table. Okay? Now, that table is right in front of you. There are the headings which have been given to you. As you can see over here, students, very carefully, that you have your element in the first column, then you have the percentage of that element, then you have its atomic mass, then you need to find out the moles of that element. How you will find this mole of that element, students? You need to divide this percentage by atomic mass. So this column divided by this column, students, will give you the moles of the element. Clear? After getting this moles of the element, you needed to find the simplest molar ratio. Now how to do the simplest molar ratio, I'll tell you in a while. Okay, so first look at the entire table, students. Okay, now first concentrate only on the first three rows. Okay, for carbon it is 40.68%, which is already given, and the atomic mass of carbon is 12. So the moles of this element will be 40.687 divided by 12. By calculations you will get it 3.390. Similarly for hydrogen, 5.085. Atomic mass of it is 1. Divide them. 5.085 divided by 1 is obviously 5.085. Last is oxygen. I hope you get this percentage of the compound, students. I've already told you, add this 2 and subtract it from 100. So you'll get 54.228. Atomic mass of oxygen is 16, and when you divide 54.228 by 16, you get 3.389. Clear? Now the next row, simplest molar ratio, students. How to get this? From this 3 moles, whichever will have the lowest number. Again, I'll repeat, the lowest number, you just need to divide all these 3 by that. So 3.390 divided by 3.389, because 3.389 is the lowest. 5.085 divided by 3.389 and 3.389 divided by 3.389 itself. So when you will do it, this is approximately equal to 1. Obviously this one will be equal to 1, and when you will divide 5.085 divided by 3.389, you will get 1.5. Now here's the catch, student. The simplest molar ratio is coming in point. You cannot have that. You always need to have a whole number here. So simplest whole number molar ratio will be, when you will multiply with this 1.5 into nearest number, you can multiply this by 2. So as I have multiplied this by 2, I need to multiply here and here also by 2. So the simplest whole number ratio will be carbon के लिए 2, hydrogen के लिए 3, 1.5 into 2 is 3, and oxygen के लिए 2. Clear? I hope this table is understood, students. Now let us go for the next one. as you have got the simplest whole number ratio, students, now you get the empirical formula of the compound. The empirical formula of the compound becomes C2H3O2. It is the whole number ratios only, students. C2H3O2. The very next step after getting this formula is empirical formula mass of the compound, students. This formula what you got, you need to find out its mass. So how to find it out? Obviously C2H3O2 hai, so 2 into 12, right? Plus 3 into 1 plus 2 into 16, correct? I have just multiplied this with their respective atomic masses. Addition of this total will give you 59. Okay, and then what you need to do, students, you need to find out and use the value of the vapor density. So what has been provided? I already told you all, students, that the molecular mass is equals to twice into vapor density. So 2 into 59. 59 is the vapor density already given to you all. That is 118. So till now what we have done, students, from the table I have got the simplest whole number ratio. Then I have got the empirical formula of on the basis of it. Then I have got the empirical formula mass of the compound. And by using vapor densities information, I have got the molecular mass. Okay, now comes the important step. Clear? So let me give you the next step, the final conclusion of the answer. So as you can see, for the value of n, for value of n, what you need to do, students? Molecular mass divided by empirical formula mass. Molecular mass you got as 118, which is twice into vapor density, and empirical formula mass you evaluated as 59. So 118 divided by 59 is whole number 2. So what will be your molecular formula, students? Empirical formula into n, where n you have already got from here. So empirical formula was C2H3O2 into n. So C2H3O2 twice. So C2 into 2 becomes 4. So C4. H3 into 2 becomes H6. O2 into 2 becomes O4. So this is your molecular formula of the compound C4H6O4. Clear, students? Okay. Let us go for the next question, students. As you can see, you need to calculate the amount of water that is in gaseous form produced by the combustion of 16 gram of methane. Now, as you know that combustion of any hydrocarbon will produce only two things, students. What they produce? Carbon dioxide and water. Okay, now for these type of questions you have a similar step of propaganda what you need to follow. The method or the procedure remains the same. So I have given the solution stepwise, students. Okay, whenever you need to find out the amount of something produced by a chemical reaction, you just need to simply follow these steps. Okay, as you can see over here, the first step is to write the balanced chemical equation or the reaction. So I have written over here the first step, students, that is methane plus when oxygen, you always get a combustion product of carbon dioxide and water. For balancing it, I have to put 2 stoichiometric over here and the 2 stoichiometric coefficient over here. Okay, then the second step is the stoichiometric coefficient represent the mole of the particular substance, student, right? Okay, so whenever you have this, you just need to write their moles below them. That is, methane ka stoichiometric coefficient is 1, so 1 mole. Oxygen का stoichiometric coefficient is 2, so it becomes 2 mole. Carbon dioxide के लिए 1, so again 1 mole. And water vapor के लिए 2, so it becomes 2 mole, students. Clear? I get it's simple till now. Then the third step. Convert this mole into the mass by multiplying them by its molar masses, student. Now molar masses आपको find करने पड़ेंगे, students. Okay, so can you see it very clearly when it is seen in your screen? Okay, so मीथेन का मोलर मास होता है 12 प्लस 4 16, इसलिए यहाँ 1 मल्टीप्लाई बाय 16. 1 was the mole, 16 is the molar mass, so 16 gram is its molar mass. Oxygen के लिए 32 students, right? So 2 into 32 becomes 64. Carbon dioxide, the molar mass is 44 students, right? So 1 into 44 is 44. Water के लिए 18, so 2 into 18, that is 36 grams. Clear? I hope this step is clear. Now you need to just calculate the mass of unknown students at last by the unitary method. Over here, if you remember the question, directly 16 gram of methane का burning ही दिया था. So from the equation itself, it becomes very clear, students, that when 16 gram of methane is burned, how much amount of water vapor is produced? 36 gram. So here from the equation only it is clear that 16 gram of methane will produce 36 gram of water. Clear? Now, in any kind of question where you need to find out the amount of the substance produced by a particular chemical reaction, the procedure remains the same. Okay? Okay, students, so let us move on to the next question. The question is, a welding fuel gas contains carbon and hydrogen only. So it's a hydrocarbon. Burning a small sample of it in oxygen gives 3.38 grams of carbon dioxide and 0.690 gram of water only. Obviously, that a hydrocarbon, when it will be burnt, it will give only carbon dioxide and water. A volume 10 liter measured at STP of this welding gas is found to weigh 11.6 grams, students. You need to calculate the empirical formula, molar mass of gas, and the molecular formula for the gas. Okay, so now let us move on to the first part of the solution. The first part of the solution, as you can see over here, students, on your screen, what I have done is I have assumed something. See, obviously the molecular mass of carbon dioxide is 44. So can I say 44 gram of carbon dioxide contains 12 gram of carbon? In the question, you have been given 3.38 gram of carbon dioxide. So 3.38 gram of carbon dioxide will contain how much carbon? Simple unitary method, students. 12 into 3.38 divided by 44. So that is 0.9218 gram of carbon. Similarly, I have done it for hydrogen, students. Can you see? 18 gram of water will contain 2 gram of hydrogen. So 0.690 gram of water will contain how much? Again, simple unitary method, which is 2 into 0.690 divided by 18, which will come into 0.767 gram of hydrogen. Now, why I did this, students? To get the total mass of the compound. Can you see over here? What I have done, I have taken the mass of carbon, what I got, and added with the mass of hydrogen, what I got. That is 0.9218 plus 0.0767. You get the total mass of the compound as 0.9985. Clear? So, the compound contains only carbon and hydrogen, and the total weight of the compound is 0.9985. Now, what I have done, students, as you can see, I have calculated the percentage of carbon and hydrogen in the compound. The percentage of carbon in the compound will be given as 0.9218 divided by 0.9985 multiplied by 100. That is 92.32%. Similarly, percentage of hydrogen on the compound will be 0.0767 divided by the total mass of the compound what I got, multiplied by 100, and that results as 7.68%. This way, I got the percentage composition of carbon and hydrogen in that gas. Clear? Now, the first part, calculation of empirical formula. You remember the table, students, what we had discussed? Yes, so that is the same table what I have taken over here. I have taken the elements carbon and hydrogen, the percentage of it what I got from above, and I also have the atomic masses. Obviously, carbon के लिए 12 and hydrogen के लिए 1. So, the moles of the elements, student, कैसे मिलेगा moles of the elements? I just have to divide the percentage with the atomic mass. So, for carbon, I will take 92.32 divided by 12, which is 7.69%, student. For hydrogen, 7.68 divided by 1, which is obviously 7.68%. For simplest molar ratio, students, 7.69 will be divided by 7.68, right? Which will be approximately equal to 1. And 7.68 divided by 7.68 obviously will have 1. So the empirical formula, students, of the gas kya nikla? CH. Clear? Now, obviously, the next step comes the calculation of molar mass of gas. The calculation for molar mass of the gas कैसे रहेगा, students? Like this. 10 liter of the given gas at STP कितना weigh कर रहा था, students? 11.6 gram. So 22.4 liter of that given gas will contain how much? 11.6 multiplied by 22.4 divided by 10. So you get 25.984 gram. Again by simple unitary method. So 25.984 can be approximately equal to 26 gram per mole, and that is the molar mass of the gas. Now you have got the empirical formula, you have got the molar mass of the gas. So the next step obviously is nothing but your empirical formula mass. Remember, students, so over here right in front of you on the screen, the empirical formula mass, students, will be what the formula was CH. So the mass will be 12 into 1 plus 1 into 1, which is equal to 13. And the calculation of n, what was n students? Remember, molecular mass upon empirical formula mass. Molecular mass we got approximately is 26 and empirical formula mass from above we got 13. So 26 by 13 is 2. So your molecular formula will be CHN. What is the value of n? 2. And what is the molecular formula of the compound? C2H2. So your welding fuel gas is nothing but acetylene. Clear? Okay students, so the next numerical is based on the concept of limiting reagent. Okay, so you might have seen this also while you doing the lecture, but once again we will try to solve this. So the question says 50 kg of nitrogen and 10 kg of hydrogen gas are mixed to produce NH3 gas. Calculate the ammonia being formed and also identify the limiting reagent in the production of ammonia in this situation. So students, the first and the foremost thing for the solution, as you can see, we have done is writing the balanced chemical reaction. The balanced chemical reaction goes something like this. The nitrogen N2 plus H2 gas produces NH3 gas, right? And obviously we'll have to balance them. So 1 mole of nitrogen consumes 3 mole of hydrogen to produce 2 moles of ammonia. Okay? And the reaction is reversible, students. Okay? You might be seeing on the foot that I have also multiplied the stoichiometric coefficients with their molar masses, right? So can you see 1 mole of nitrogen? 1 mole of nitrogen gas N2 is diatomic, students. So it is 28. 3 moles of hydrogen. So 3 into 2 and 2 moles of ammonia. Ammonia's molar mass is 17, students. So 2 into 17. Clear? So it is very clear from here that 28 moles of nitrogen reacts with 6 moles of hydrogen to give you 34 moles of ammonia. Now the students, this moles can be also converted into kg also. We can say 28 kg of nitrogen will react with 6 kg of hydrogen to give you 34 kg of ammonia. So now do you get what will be the next step? Yes. What we can have is that we can cross multiply and get our answer. As you can say, 28 kg of nitrogen reacts with 6 kg of hydrogen. 50 kg of nitrogen कितना hydrogen के साथ react करेगा, right? Why 50? Because that is what is asked in our question. So simple unitary method, students, 6 into 50 divided by 28. When you do this, the answer is 10.7 kg, students. मतलब 50 kg of nitrogen को 10.7 kg of hydrogen की ज़रूरत पड़ेगी according to our balanced chemical reaction. But we have only 10 kg of hydrogen which is specified in the question. So therefore hydrogen हमारा क्या बन जाएगा? Limiting reagent, students. Clear है? Now you should also remember, students, that limiting reagent also decides the amount of product produced. जो भी प्रोडक्ट प्रोड्यूस होता है वो हमेशा लिमिटिंग रिएजेंट की क्वांटिटी पे डिपेंड करता है, स्टूडेंट्स. सो इन दिस क्वेश्चन द अमाउंट ऑफ अमोनिया बीइंग फॉर्म्ड विल आल्सो डिपेंड अपॉन द हाइड्रोजन ओनली. सो एज यू कैन सी ओवर हियर what I have done, 6 kg of hydrogen produces how much? 34 kg of ammonia. वो हमने केमिकल रिएक्शन से देखा. और मैंने हाइड्रोजन के नीचे क्या देखा है, देखो, LR. LR is limiting reagent. Okay, so 6 kg of hydrogen produces 34 kg of ammonia. तो 10 kg of hydrogen कितना प्रोड्यूस करेगा? Simple, I suppose. So 34 into 10 divided by 6, which is 56.67 kg of ammonia. क्लियर है ऑल ऑफ यू? आई होप लिमिटिंग रीजन का कॉन्सेप्ट इस क्वेश्चन से क्लियर होगा. ओके, to make the concept more clear, let us go for one more example from the concept of limiting reagent. It is asked in many schools, student, so please don't take it lightly. Okay, the question is, the reactant which is entirely consumed in the reaction is known as limiting reagent. Okay, in the reaction 2A plus 4B gives 3C plus 4D. ये अपना केमिकल रिएक्शन उन्होंने दिया हुआ है. When 5 moles of A react with 6 moles of B, then you need to find out what is the limiting reagent and calculate the amount of C. Over here reaction में जितना C produce होता है वो find करना है. Clear? So let us begin with the solution. In the solution, 2a plus 4b gives 3c plus 4d. ये हम लोग को ऑलरेडी दे दिया हुआ है, राइट? सो व्हाट वी कैन से दैट 2a moles या kgs of A always reacts with 4 moles या kgs of B to produce 3 moles या kgs of C. Remember? So what we can do is over here have that same unitary method again. Can you see over here, all of you? 2 moles of A reacts with 4 moles of B. हमको क्वेश्चन कितना पूछा है? 5 moles of A को कितना चाहिए होगा B? तो अगेन सेम यूनिटरी मेथड स्टूडेंट्स, 5 into 4 divided by 2 which is equal to 10 moles. मतलब 5 moles of A को 10 moles of B चाहिए होगा, राइट? बट हमें कितना दिया हुआ है इन द क्वेश्चन स्टूडेंट्स? 6 mole. So we have only 6 moles of B and therefore B is the limiting reagent. Clear है? Now I told you in that question also that limiting reagent is only the factor which decides the product being formed. So limiting reagent decides the amount of the product produced. इसी वजह से हमें C का जो amount form होगा वो B से ही पता चलेगा स्टूडेंट्स. So as you can see on the screen, how you can calculate it is very simple. 4 moles of B produces 3 moles of C. ये हमें रिएक्शन से पता चलता है. और हमें कितना B दिया हुआ है? 6 moles. So if 4 produces 3 moles of C, 6 moles of B produces how much? So simple unitary method again, 6 into 3 divided by 4. So that is 4.5 moles of C is being formed. ठीक है? So I hope with this question the concept of limiting reagent is really very clear. Okay?